how to find empirical formula and molecular formula. Okay. So after discussing stoichiometry, we would be discussing the remaining concepts, including limiting reactant, excess reactant, percentage yield, percentage purity, empirical formula, molecular formula. Starting from empirical formula, this is very easy. Of course, you have also learned in your IGCSE. Empirical, what is empirical formula? It's the simplest formula, or it's known as experimental formula. Experimental formula. Okay. Uh, let's suppose I am saying that H C6H12O6. This is glucose. Okay. Um, I'm asking, is this empirical? You are supposed to say no. Why? Because it can be simplified further into this. What I did, I have divided the formula by the smaller number. That is 6. Okay. I got this. This is the simplest formula. This is your empirical formula. This was your molecular formula. Molecular formula is not a simple formula. Okay, molecular formula is going to tell you actual elements that are present in a compound. But empirical formula can only tell you the simplest ratio between the elements in a particular compound. So there is a difference. Whenever the molecular formula is given to you, whenever the molecular formula is given to you, so you can find out the empirical formula. How? You have to divide it by any number. Let's suppose this is the formula for ethane, C2H6, ethane. Like, can you tell me empirical formula? Of course, yes. Empirical formula would be CH3. What I did, I have divided the formula by 2. I have divided the formula by 2. I got the empirical formula. Now it cannot be simplified further. Now it cannot be simplified further. Okay? It cannot be simplified further. So of course, this is called empirical formula. This is called empirical formula. Okay? Set? Easy? Okay. So according to examiner point of view, how we are going to find out the empirical formula? What are the steps to find this empirical formula? So the step number 1 is find the number of moles by the given mass or a percentage. Sometime mass is given to you, sometime percentage is given to you. Okay, sometime mass, sometime percentage. Okay, and then step 2 says find the simple mole ratio. I would be telling you how to find the simple mole ratio. And then step number 3 says if you didn't get the whole number in this, step number 3 days says you have to make it a whole number. There is no any concept of rounding off the data basically in this. You have to make it a whole number by multiplying it with any number. Okay, this is important to know. And also remember, it is possible that the molecular and empirical formula is the same. It is possible. Let's suppose in this case, water, molecular formula is equal to empirical formula because you cannot cancel this too. What about this oxygen? Oxygen is 1. Okay, oxygen is 1. When we are going to cancel any number, so we have to take the common number through which I can cancel the whole things. Yeah, I know if I would be taking 2 in the case of water, so the two would be canceling each other. But what about oxygen? That's the reason. Water is itself empirical formula and also the molecular formula. So it is possible that the molecular formula is equal to empirical formula. So they can be same they can be different. This is the concept. They can be same, they can be different. Okay. Acha ji. So this is the question. Many organic compounds contain carbon, hydrogen, and oxygen only. An organic compound R has the following composition by mass. Calculate the empirical formula of compound R. Okay. You have to calculate the empirical formula. So the percentages are given to you. I would consider this percentage as mass. I would consider this percentage as mass. Okay. So step number one, I'm going to find out the moles first. So 12 is the atomic mass of this carbon, 1 is the atomic mass of this hydrogen, and 16 is the atomic mass of this oxygen. Mass over AR, mass over AR, mass over AR. I would be getting the moles. I would be getting the moles. Mass over atomic mass. I would be getting the moles. Okay. Then, then in the next step, I got these answers after the division of this number. Then of course, step number two says you have to find out the simple mole ratio. You have to find out the simple mole ratio. Okay. So which is the smallest number? Of course, 1.16. I'm going to divide the whole numbers by 1.16, which is the smallest number. This is the method basically that you must follow. This is the method. Okay. This is the method. Right. Okay. So I got 5, then 10, then 1. So the formula is C5H10O. This is your empirical formula. It's quite easy to determine empirical formula. It's very easy. It's very easy. Okay. Sometime you will see that you are not getting the whole numbers. You are getting the odd numbers. Then what you would do? Of course, you have to multiply this by any number. It starts from 2. Start from 2. After multiplying this by 2, again, still you're not getting the whole number. Keep on doing this with 3, with 4, with 5. Maximum, generally, we got the whole number with 4. I think so. Okay. So we would be doing some questions in that we would see that. In that we would see that okay, we would not be getting the whole number after doing this step, and then we have to multiply that answer by any number. That should be the whole number. That's the that's the main thing. Okay, got it. So we have multiple questions. I would be telling you after the molecular formula. You know, molecular formula would be giving you the information, the whole information. Okay, like means that let's suppose this is the molecular formula and this is the method to find out the molecular formula. Okay, N is equal to molecular formula mass divided by empirical formula mass. What is N? What is N? We have to find out that N. Let's suppose in this question they are saying compound S has the empirical formula CH2O and a relative molecular mass of 60. Com- Calculate the molecular formula of compound S. So this mass is given to you, that is 60. This mass is given to you, that is 60. Okay. And 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 empirical formula is also given to you. An empirical formula is also given to you. That is CH2O. You have to find out the molecular mass of this empirical formula, that is 30. I'm going to divide these two numbers. I would be getting the value of N. Then I would be multiplying this N by this empirical formula. Then I would be getting this molecular formula. So to find out the molecular formula, you must know the empirical formula. Without empirical formula, you cannot find the molecular formula. Okay, you cannot find the molecular formula, right? Okay, so it's very easy. Okay, okay. Then we have a concept that is called limiting reactant. That is called limiting reactant. You know what is limiting reactant? The species which consumes first. The species which consumes first. Like let's suppose if you have 5 t-shirts and 4 trousers. So of course you would be having 4 suits in total. Why not 5? Because trousers are limited. Trouser would be ending. If you would be making the 4th suit, then there would be no trouser. This is your limiting reactant. And of course, this is more in quantity. It's called excess reactant. So in this, examiner would be asking to identify the limiting reactant. So how we would be identifying like what is the limiting reactant? Okay. So we have some methods and directly uh, like you can say most of the time he would not be mentioning that this is the question of a limiting reactant. You would be doing some past papers, then you would be getting an idea. Okay, most of the time he would not be mentioning you that this is the question related to limiting reactant. Okay, you have to identify by yourself. So the hint for this question is that you would be given more than one data. Like in simple general mole questions, it is observed that we did some papers in the last class. One thing is given to you and another thing he is going to ask. Generally, of course, in general practice, one thing is given to you and one thing is he's asking. But in this question, limiting reactant, they would be giving you the more than one thing. Like let's suppose this is the question. Okay, when 2 grams of nitrogen reacts with 25 centimeter cube of zero point 0.1 mole per dm cube of hydrogen to form ammonia. Find the mass of ammonia formed. Now you got confused. Like with whom I have to take the mole ratio of ammonia? Like with nitrogen or with hydrogen? है ना? पुराने सवालों में क्या होता था कि एक दिया हुआ है हम फाइंड आउट कर रहे हैं. There is no confusion. But right now we are confused like what we are supposed to do. We have to take the mole ratio of ammonia with the nitrogen or with hydrogen. So the limiting reactant would decide. ये तो ऐसा ही है कि how many suits I would be having. So of course you must know like which is in the minimum quantity. Of course the trouser was in the minimum quantity. So I have got an idea of the total suit. That would be 4. So without identifying the limiting reactant, you cannot calculate the product. It's very simple. Without calculating the limiting reactant, you cannot calculate the product. So first of all, you have to identify the limiting reactant. How? What I did, you can see I found the moles of nitrogen. The mass is given to you. This is an MR of nitrogen. And I got the moles of nitrogen. Okay, I got the moles of nitrogen. Then concentration and volumes are given to you. Then I got the moles of this hydrogen. Okay, I got the moles of this hydrogen. Okay, you know, directly he's not asking the limiting reactant, but we have to find it. So this is a shortcut method to find out the limiting reactant. What I did, find the moles of each reactant, then divide each mole by the coefficient given in the equation. In equation, the coefficient for nitrogen is 1. The coefficient for hydrogen is 3. So I have divided this mole by 1 and this mole by 3. Then after division, I got this and this. Now you have to see this, which is the smaller answer. Of course, this is the smaller number. So I can say hydrogen is a limiting reactant. Hydrogen is a limiting reactant. So what you would be doing, you would be having the mole ratio between hydrogen and ammonia, not with nitrogen. This is the main idea. That's the reason we were identifying the limiting reactant. Okay. So according to equation, it has 3 moles of hydrogen, 2 moles of ammonia. I got the moles of hydrogen, that was 0.0025, and this is X. So cross multiply, then you would be getting the moles of ammonia. So I have found the moles of ammonia with the by taking the mole ratio of hydrogen, not the nitrogen. After finding the moles, I would be finding out the mass as well. It's very simple. Hmm? Okay. So this is the mass of you can say ammonia. Okay. Simple. चलें जी. Then see this question. Find mole of SO3 formed by the reaction of 2 mole of sulfur dioxide and 0.5 mole of oxygen. 0.5 mole of oxygen. Okay. I have given you the 2 moles of like the reactant side. Okay. Find the moles of SO3 formed by zero point 0.1 mole of SO2 and
Sir,
0. Yes. हम्म.
Sir Chadwick,
ये कौन है भाई? Who is Talha Kamran? हम्म. शाफे. Okay. कौन है भाई ये? ओ भाई भाई भाई. ओके. तलहा कामरान. बाय बाय. ओके. माय गॉड. ओके. So find mole of SO3 formed by 0.1 mole of SO2 and 0.25 mole of oxygen, O2 that is, okay? So this is your equation, 2SO2 plus O2 gives 2SO3, okay? So uh, I have to find out the moles of SO3 formed, okay? I have to find out the moles of SO3 formed. Just give me 1 minute, just give me 1 minute, okay? Just 1 minute. Okay, yeah, yes. हम्म. हाँ जी, तो अब आपको ये सोचना है कि you have to take the mole ratio between this and then with SO2 or O2. Of course, first of all, you have to, of course, you have to find out the mole ratio. Like you have to find out the limiting reactant first. Okay. So what is the coefficient of SO2? What is the coefficient of SO2? Of course, this is 2. So 0.25 by 2. And what is the coefficient for oxygen? That is 1. 0.1 upon 2 and then 0.25 upon 1. Okay, what I did, I'm going to divide the moles of SO2, that is 0.1, by the coefficient of SO2, that is 2. And then I'm going to divide the mole of O2, that is 0.25, by the coefficient of O2, that is 1. Then this would be 0.25. Am I right? This would be 0.25 or 0.05. What do you think? 0.05, na? And this would be 0.25. Okay. So after division, which is the smallest number? After division, which is the smallest number? Hmm? So of course, 0.05 is the smallest number. So SO2 is a limiting reactant. So SO2 is a limiting reactant. Okay. SO2 is a limiting reactant. SO2 is a limiting reactant. Simple, simple, simple. Now you got the limiting reactant. Now you can find out the moles of SO3 very easily. Kaise? SO2, then SO3. What's the mole ratio? 2 is to 2. I got the moles of SO2. That was 0.1. This is X. So X is equal to 0.1. Simple. It's the moles of SO3. So what we have learned, you are not supposed to you are not supposed to find out the moles of the product directly. Okay, you have to first find out the limiting reactant. You have to first find out the limiting reactant. Okay, after finding out the limiting reactant, after finding out the limiting reactant, then you can find out the product. Okay, that's the main criteria for this limiting reactant. Okay. So how you can identify that this question is related to the limiting reactant? Remember, basically, um examiner would be giving you the data. Okay, like he may give you volume, he may give you the concentration, he may give you the like mass. Okay, of both reactants. So you have to first find out the moles of each reactant, then you can find out the limiting reactant. After doing this all, then you are supposed to find out the mass or anything of the product side. Okay. So it's the concept of limiting reactant and excess reactant. Limiting reactant and excess reactant. Okay. Challenge. Then what's the next concept is to find percentage by mass. Is to find percentage by mass. Okay, percentage by mass. So percentage by mass means, let's suppose we have different fertilizers. We have different fertilizers. Let's suppose I tell you that you have ammonium, phosphate, and you have ammonium sulfate. Okay, which is the best? The best one fertilizer is that in which you have the higher percentage of nitrogen. So you have to find out the percentage of nitrogen in both compounds. What you are supposed to do, okay? So percentage of nitrogen is equal to the mass of nitrogen. How many nitrogens we have? 3 nitrogens divided by the total. Divided by the total. That is this. And then percentage of nitrogen in ammonium sulfate. How many nitrogens we have? 2 nitrogen divided by the total. Divided by the total multiplied by 100. Then you have to put the masses into that. Then you have to solve it. Then you would be getting the percentage of nitrogen. Okay, that is 3 into 14 divided by 14 plus 4 multiplied by 3 plus 4 phosphorus, that is 31 plus 4 into 16 multiplied by 100. Okay, then it would be equal to 2 into 14 divided by 14 plus 4 multiplied by 2 plus 32 and plus 16 times 4 multiplied by 100. Okay, so after solving it, you would be getting the percentage of nitrogen. Then you can decide which is the best. Then you can decide which is the best. Okay, it's very easy. This is called percentage by mass. This is called percentage by mass. Okay. What's the answer? Answer बता दो जरा. According to the new syllabus, percentage yield is not included in this topic. Okay? Percentage yield and also the percentage purity. You would not ask. What's the answer? भाई जल्दी बताओ.
6.1.
6.1%. Okay. और दूसरे का?
नो सर, दूसरे वाले का 6.1 है.
Okay. पहले वाले का?
28.2.
Oh, okay. 28.2. सही है जी. Okay हो गया. So I think it's very easy to find the percentage by mass of anything. कुछ भी कर लो आप. अच्छा, let's suppose we have a washing soda, that is sodium carbonate, hydrated sodium carbonate dot 10H2O. You can also find the content of water in terms of percentage in this washing soda. बता सकते हो आंसर क्या होना चाहिए? Fast. Make sure कि आप लोग इसी तरह कर रहे हो. Okay. Mm-hmm. What's the answer? What's the answer? Mm-hmm.
62.9.
62.9%। बहुत इजी कॉन्सेप्ट है, बहुत इजी है, एकदम बेबी कॉन्सेप्ट। ओके सो see some MCQs related to this, okay, how it comes in paper one. Uh, okay. Yeah, moles. hmm hmm See this question number 19. Question number 19. Yes. ट्राई करो फिर मैं बताता हूँ। हाँ जी, क्या आंसर है? जल्दी जल्दी फटाफट। जल्दी जल्दी करो यार फटाफट। नो। Okay, how many moles are given to you for sodium azide? That is 1 mole of 1 mole. Okay, sodium azide ka 1 mole. NaN3. NaN3. Then nitrogen. Okay, set. According to equation, we have 2 moles of NaN3. And how many moles of nitrogen we have? How many moles of nitrogen we have? Hmm? How can you find out this? Yes. What do you think about that? Can anyone tell me? Yes. Dua, Iman, Hafsa, Shafe, Sophia, Tala, Umna, Zaina. What do you think? How can I take the mole ratio? How can I take the mole ratio? Yes, Zana, what do you think, Zana? कुछ तो बोल दो, कुछ तो करो, कुछ तो बोलो. चलो, I am saying the answer is B. चलो, I am going to give you hint. Answer is B. But how? How the answer is B? ये तो बता सकते हो. थोड़ी सी हिंट दे दी मैंने आपको. The answer is B. But how? Just a minute. Okay. I'm still solving. Okay. 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 Take your time. I don't want to tell you it's your practice. Keep on solving this. हम्म. पहुंचे कहीं तक? शाफे, शाफे, क्या कहते हो शाफे? कुछ तो बोलो. हम्म. बड़ा मुश्किल सवाल पूछ लिया मैंने यार. हम्म.
Sir, I'm getting the answer as 0.15 and it's not even one of the options.
ओ, ओके. 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 अच्छा जी. हाँ भाई, सूफिया. ताला, ताला, कुछ तो बोलो. ताला, व्हाट डू यू थिंक अबाउट दैट? चलो, आई एम टेलिंग यू दिस. ओके, आई एम गोइंग टू टेल यू दिस. According to equation number 1, according to equation number 1, 2 moles of NaN3 gives 2 moles of sodium. Okay. Okay. Then 1 mole of NaN3 would give you would give you hmm, 1 mole of give you 1 mole of Na. Okay. 1 mole of Na. Okay. Set. According to, then I can say 2 moles of, then I can say like 10 moles of sodium. If you can see equation number 2, 10 moles of sodium, 10 moles of sodium gives 1 mole of nitrogen. 1 mole of nitrogen. So 1 mole of sodium would give you how many moles of nitrogen? That is X. That is X. Okay. So X would be equal to 1 by 10, that is 0.1 mole. According to equation 2, I got the moles of nitrogen, that is 0.1. And according to equation number 1, I got the moles of nitrogen, that is 1. है ना? I got the moles of nitrogen. That is one. Nah, not one. According to equation number one, I'm getting 3 moles of nitrogen. है ना? Let me tell you again. According to equation number one, according to equation number one, 2 moles of NaN3 gives you 3 mole of nitrogen. Okay. So if I have 1 mole of NaN3, so what is the value for X? X would be equal to X would be equal to what's the answer? X would be equal to what? Yes, 1.5.
1.5.
Exactly. This is according to equation number one. This is according to equation number one. Let me tell you equation number two as well. According to equation number two, according to equation number two, 10 moles of Na gives 1 mole of nitrogen. Okay, 1 mole of nitrogen. So if I have 1 mole of Na, so how many moles of nitrogen I would be having? Of course, this is 0.1. So the total would be equal to 1.5 plus 0.1, that is equal to 1.6. That's the question. Simple. Now you can get an idea, okay, how is the difficulty level of these questions. Okay. Um, Let me tell you another question. Yup. See the same question. Like it's related to the percentage by mass. So what do you think about that? Which compound is going to have 54% calcium? You must know the formula. This is calcium hydroxide, CaOH2. This is calcium nitrate. This is calcium oxide. This is calcium sulfate. Okay. Simple, 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 simple. Yeah. What's the answer? So what you have to do, as I told you, जिस चीज की percentage find out करनी है, it should be in the numerator divided by the total multiplied by 100. Of course, calcium upon calcium hydroxide multiplied by 100. Calcium upon calcium nitrate multiplied by 100. Calcium upon calcium sulfate multiplied by 100. Calcium upon calcium oxide multiplied by 100. You would be getting the percentages. The one which is going to match with this percentage, that is 54%, that would be your correct option. You know, working is there, but it's easy. It's easy. So after doing practice, you would be solving it smoothly. Okay.
Is it A?
I think so. Calcium 40 upon what's the molecular mass of calcium hydroxide?
74.1.
74.1. Okay. So if you are getting 54%, so that's okay. That's okay. No problem. Okay. Okay. So then you are supposed to solve the recent questions. Okay. You are supposed to solve the recent question. And if you are unable to do any of the question, then we would be discussing like the query class. We would be discussing in the query class.